Hello. How's everyone doing? I'm not confident that the audio is working well, so I'm going to check real quick. Do. Charlie, my account, audio. And I'm getting an ad. Who knew? All right. I think that should be what I need. All right. Welcome, everybody. It's been a while. So just to get started, I think briefly, notice I'm streaming from a new place. Why? Because I have a new apartment. Why? Because I'm in a new city, in a new state, at a new job. I am building rocket engines with a company called Kerbal Space Industries in Colorado now. And so I have just finished moving out here. Yeah, so I've been setting up the apartment. This is going to be my workshop eventually. 3D printers, shelves with rocket engine parts, pegboard that's going up on the wall behind me, all kinds of fun stuff. It'll be a great place. I've got a whole room to film videos in now instead of just my bedroom, which is going to be awesome. Anyway, but I've spent the last, since December 10th, I've been moving. And I finally got the computer all set up, so I figured I'd break it in by playing some Kerbal Space Program. I've got a brand new monitor. It's a 49-inch Samsung wide aspect ratio screen, and I'm actually thrilled. So it's a lot of fun because now I've got chat here, streaming software here, and then I still have a full-size Kerbal Space Program window. It's way too much fun, and I got a great deal on it too. Yeah, thanks for hanging out, everyone. We're just going to begin at the beginning. We've got a blank career save, and let's see how far we get. I'm saying it's a bit loud. All right, well, we can chill on that. Okay, so, wow, it's been a while since I've started here. We've got a dirt runway, a flat, compacted dirt pad, and what appears to be some form of shed for a vehicle assembly building. Well, when we begin at the beginning, we have no other choices. So, and it costs money to hire astronauts, so we shouldn't do that yet. And we don't have any research, so I guess the first thing we have to do is take a contract. Oh, Ben One Techie. Not only do I have mods, I have so many mods on this. You'll see that I have just about every graphics mod that you can imagine. If you've been on stream with me before, you may have seen that I was running yesteryear's tech. Hang on one second. Yeah, this is the graphics card that I pulled out of my computer. It's a NVIDIA 550 Ti. It's got 1 GB of memory, and it was struggling. The backside of it is covered in a fine patina of dust, and it's just not very happy. It smells a little toasty, too. And I picked up a new NVIDIA 1060, so everything is running very smoothly now. Okay, this is still not where I wanted to be. I wanted to mission control. There we go. Okay. Let's see. Oh, Porky. Cool. If I'm in Utah, I'll let you know. I'll probably be out at a research launch there sometime or another. Unknown comment. How do I find thrust from combustion reactions? That's a good question, and it depends on how you combust propellants. In general, what you're going to do is an energy balance, where you figure out how much energy is released by the combustion of the propellants, and then figure out how efficient your nozzle is, and then you figure out how much of your propellants you burn, and then you know a velocity and a mass flow, which you can use to get the thrust. But your mileage may vary, and you may have better methods like CFD, or worse methods, like just building one and putting it on a test stand. Nathan, is my new internet not fast enough for 1080p? Is it not in 1080p? It should be. I think I'm streaming in a weird aspect ratio, 1152 by 648. Let's see. I should be able to stream in 1080. I have 150 megabytes up, or at least that's what I'm paying for. So if they're not giving that to me, I need to complain. Yeah, no, it should be working. I don't know why it would not be showing up in high resolution. It is only 480p. All right, well, let me try one thing before I write off the stream quality. Let's try... All right, I will be right back. I'm going to have to restart the stream just to get the resolution to read. All right, is that better? You wouldn't know. Let's, give me 1 second. There we go. Is that better? Wow, no, that is not very good. Wow. Oh no, I'm getting it in 720/60 now. Nathan, I don't know what's up with you. Anyway, that's enough boring stuff. Let's play. What we're going to do first, gather scientific data from Kerbin, launch our first vessel. That seems like kind of a priori requirement for any of the other ones. And I guess we won't be orbiting Kerbin anytime soon, so we'll start with this one. Give us a quick crew report before launching. It's fine if the lights on the control panels are flashing, just give it a swift kick. All right, well, since lights on the control panel flashing means that you're at least getting electricity at the control panel, I'll take it. So let's go see what parts we have. This is my first time playing with this stack of mods. This is my first, like, really heavily modded game of Kerbal Space Program since they added 2.5 meter parts, because I actually have the horsepower in the computer to run it now. So let's see, do we have decouplers? No, we have none of that. So it's just going to be an engine and a parachute. Parachute. Oh, we have a big parachute. I didn't realize that real chute had options. Oh, that's a really big parachute. Okay, we won't be using that one. All right, well, there's obviously only one name for this rocket, which is the Upgoer 1. And let's go try it. Brazilian, hopefully we don't spend too long at the beginning. So while we're waiting on this to load to the pad, oh, nope, it's already here. There's some snazzy purple thing here. That's probably an unloaded asset. Oh, and as always, check yo staging, because that would have been bad. There we go. And we go up. And really, I could have saved money by not putting this much rocket fuel in this rocket. Let's take a crew report. There we go. Yay, fun. Let's see, what's our other contract? Achieve goal. Recover or transmit science experiment from Kerbin to achieve this goal. All right, so we'll get that as well. Alan, gas and air could work as a rocket fuel. It wouldn't be a very good rocket fuel, and it would be really, really challenging to ignite. This feels like an unloaded IVA asset. I don't know what it is, but I'll debug it the next time I restart the game. For now, it's just a purple square. We don't actually care. And so now, the other important thing is that if you don't deploy your parachute soon enough, the rocket will flip around and go stable the other way and lawn dart into the ground, killing your Kerbal. So you need to make sure that you deploy your parachute before it does that, which we have now done. So now all there's left to do is get to the business of falling back to Earth, because as the saying goes, what goes up must come down. The Redstone Hive. We don't have goo modules yet. That's how at the beginning of the tech tree we are. And we've got a parachute, and we'll land right in front of the astronaut complex to make all of Jeb's friends jealous that he got to go to space and they didn't. Dun 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 dun. Cheers! We got the whole thing back. And let's do an EVA report real quick. EVA report. Keep that. F. Board. And let's get out again, and we can get a second EVA report. EVA report. All right. And then we'll recover Jeb, and then we'll recover the craft. All right, and then we need to recover this vessel, which got us another 21 science. So we will grab some rocket engines and some more experiments. We got a magnetometer, some Kerbal attachment system stuff, some more antennas, a decoupler, a few new antennas, and a thermometer. And that leaves us with 10 science, which is not enough for any of these research nodes. So it's time to head back to Mission Control and get another contract. All right. We can test a parachute in flight over Kerbin. We have to be between 6,000 and 11,000 meters and going, between 6,000 and 11,000 meters and going between 180 and 290 meters a second. That may not be really easy to do. Test the decoupler splashed down. This one should be easy. So we're going to take this one. Let's see. Haul the chute flight cone. Flying 5,110 meters. Okay, so we're going to do this one as well. And so now what we're going to do is we're going to play with the amount of cosmic exploration. It depends on what repellent and where you live. And I'm not going to give rules in general because I know the rules for where I am and what I do. And if you live somewhere else and do something else, you could get in trouble by following the advice I give. But coming up in Solid Rocket Motors episode 4 or 5, I think, I don't remember when I edited that in, there is a discussion about where you can find what your local rules are so you can know what to do. Although cosmic exploration, hybrid rocket propellants are considerably less regulated than solid rocket propellants because hybrid rocket propellants are inert by default, although there may be local laws on nitrous oxide. But in general, hybrid rockets are fairly unregulated. Oh, cool. There's a new, I didn't realize there were new paint schemes for the small boosters. We're going to switch the parachute on this to the big parachute, because this is what we got the contract for. This will give us 4 seconds of burn at 9 TWR. All right. Upgoer 2. When will Solid Rocket Motors 2 come out? Very soon. Actually, I might be able to like do a preview on the stream. Let me see. Maybe I can do that. Would you guys like to see a preview of Solid Rocket Motors 2? Let's see, SRM2. The Rocket Kid. Liquid rocket engines is still happening. I have the episodes through episode 9 filmed, but I'm lazy and hate editing. After that, it's going to slow down even more than it already has because I don't have my machine shop anymore. So now I have to send parts out to vendors to get them manufactured. But I do have all of my valves in, so I can start running tests on my plumbing system. I spent like a gazillion dollars, like literally actually like $3,000 on valves and regulators. I bought them from Swagelok so that they would just work because they didn't work after a lot of trying. Jordan, I work at a place called Agile Space Industries in Colorado, and we build in-space propulsion systems using hypergolic propellants. So there's a really great picture I took of me on my first day wearing a scape suit. Well, it's not technically a scape suit, it's an SCBA suit. But it's for working around nitrogen tetroxide and hydrazine. All right, well, let's launch this rocket and then see about pulling up the Solid Rocket Motors 2 preview. T-minus 5, 4, 3, 2, 1. The Brazilian Kid, Cooking with Charlie 2, is scheduled the next time I see Joe Barnard, which is probably going to be a while since Joe is far away. The Redstone Hive, methanol is toxic, ethanol is not. Most of the other differences are immaterial. All right. There we go. All right, so we got that contract. And if I was thinking, I would have tried to get this contract and the other contract at the same time. But I guess we're not going to, so we'll do that. Let's see. Jordan, yes, it is a ton of fun. I have been working for about 2 weeks now, and I really love it. It's a much smaller group than any of the previous places I've worked at, and my coworkers are absolutely brilliant, and I've learned a ton. I've been really excited to learn how to work with hypergolic propellants. That's not... when I was at the Cape, I didn't do payload integration, so all the payloads came into the hangar with the hypergolic fuels already in the payload, in the fairing. So kind of the rule was don't drop the fairing, don't open the fairing, and for the love of God, don't spill the hydrazine. So getting to actually handle the stuff, which I have not had to do yet, but I've been around it, has been pretty cool. And yes, absolutely, we will be safe. The company I'm working at has been working with hypergulls for a while now. So I think they have a pretty good idea of what's going on, and I'm excited to learn from them. Okay, so let's get a crew report, because I'm supposed to be doing science, and oh wow, and I've kind of forgotten to do that while I've been talking, so a little more focus on the game. Whew, all right. Nathan, is there a BPS KSP multiplayer server? I wasn't aware there was. Has Joe been holding out on me? Let's see. All right, we got Jeb back, and we will recover this. And that got us 18 science, which should be enough science that we can get either that or this, but not that. And I want this because it has the new science experiments. So, oh, no, there's one more thing to do, though. So speaking of Kerbal Space Program multiplayer, I have been around the Kerbal Space Program community a very long time, since 0.11, 2011, it's been 9 years. It was actually just today when I was installing the mods onto this save that I realized it's been almost 7 years since Scott Manley's Interstellar Quest started. And if you haven't seen it, Interstellar Quest, amazing Kerbal Space Program series by the excellent, as always, Scott Manley. And it just kind of like seems like that should have happened more recently than that. But yeah, so I remember when Harvester promised us that KSP would actually get multiplayer. And it was after the first set of mods came out with Kerbal Space Program multiplayer. I think it was like Dark multiplayer came later. I don't remember what the first one was, but that was like 2015 maybe now. It was a long time ago. And that never happened, and I guess I'm kind of meh about that. It's sad, but Kerbal Space Program isn't really like a multiplayer kind of game. Or at least it isn't kind of by default. Let's see. To perform the test, activate it through the staging sequence while at the launch site. That's like a give me because I can just use that as a booster. Test it between... So this is going to be the hard one. This is one we can definitely do. Oh, no, because I have to do the one with the... So let's do that first. So let's build a vehicle real quick with a spare decoupler. Alright, I will add goo to the craft this time. Sorry. Alright, so we'll put the parachute back on it. What we're going to do this time is we're going to add a decoupler. And we're going to deliberately fly this thing into the ocean so we can test the decoupler. And I need someone to tell me in the chat, where do you get the most science from the mystery goo? Should I use this thing while I'm in flight, or should I use this thing... You know what I'm going to do? I'm just going to put a bunch of them on it. See? All of the science. And we're also going to put a bunch of thermometers. 1, 2... Because we'll get like 100% of this back, the value of this back. And then we'll put a bathymetry module on it. Yeah, here we go. Alright, we're going to do all the science on this flight. Make that nice and cheap. Launch. Elliot Daly, how did I get my job? Well, I interviewed for it, and I am good at the things that I'm good at. My job, in addition to space propulsion, is I'm a vehicle engineer and kind of a product lead on a NASA program, and if things work out, I'll be the Phase 2 PI on this NASA contract, and it's been a really awesome experience. I think I can say that it's a lunar mission, and it's essentially attempting to leverage advances in technology to make getting sample material back from the moon easier. Yeah, so it's been really exciting to work on that project. I think I've learned a lot doing what I have already, and I think that I can bring a lot of value to like developing this system. And I think my boss and the person who hired me agreed. All right. Oh boy. Uh-oh. What happened there? I didn't mean to stage. Oh, that's what happened. Okay. Whoops. So, say it with me, folks. Check your staging. And this is going to be weird because the decoupler needs to come after the parachute. So we're going to log pressure, observe a mystery goo, and get a temperature. And then we're going to launch sideways. Unknown comet, you are correct. However, we are a little premature on the going to other bodies kind of thing right now. So that's the parachute there. So now we want to get the mystery goo and a barometer and a thermometer. we will grab a second one of these. And then we will float down into the ocean. And then we will get our contract here by testing the TD12 decoupler. And then we will do our bathymetry module. By doing our bathymetry module, let's see, log temperature, observe mystery goo, get a crew report. All right, so now what we're gonna do is we're gonna try and like jimmy this so that it's underwater, air quotes. There we go. And that got us another 6.4 science, and now we can recover the vessel. Let's see. Scott Manley, yes, check your staging. You get 5 science if you land on the sun. Redstone Hive, I don't believe you, but just in case it's true, later in this career save, we will try. That's my promise. We will try landing on the sun on Kerbal at some point in this save file. All right. That was 48 science. So we're going to recover this and get the money back and come here. And we want to escape the atmosphere. So what we're going to do is we're going to take this interlude and see if I can set up, let's see, SRM preview. I'm going to try and set up the SRM view. All right, so after the finish pass, and what I've got here is I've got a pair of calipers. What I'm doing is I'm just checking the dimension to make sure I hit what I was going for. So I was aiming for 2.125 inches on the OD. This is technically a direct read, which you're not really supposed to do. A micrometer would be a really useful tool here. But this reads to me as 2. This reads to me as 2.499 inches. 2.12499. So that's the reading right there. These manual calipers are wonderful, wonderful things. I have to get better at using them, but so this is definitely close enough for us to count this as hitting our mark. So the question now is, what's next? And I think, if I turn the camera real quick, you can see that I need to clean up this end of the case. I had to use this to chuck it up. And I was really optimistically hoping I'd only need enough material to leave the thrust ring, so I'd only have to turn the thrust ring on the other side, but that's not going to be the case. So I'm going to flip it around and clean that up, and then we'll get on to the retaining rings. All right, folks, so this is... All right. I think that was the end of that video. So that was me making the motor case for the SRM series, and that case is actually done and finished, and it looks amazing. I got it anodized by a professional vendor, so it is the most spectacular shade of blue. I might grab it and show it off later. And I've actually already cast the propellant for the SRM finale. I just haven't tested it yet. I vaguely thought about testing it at Joe Barnard's place while I was there, but his test stand was not as big as I hoped it was, and my test stand was much too big to test it. So I was kind of in an awkward place to test this motor. But now that I'm out here in Colorado, I have to buy a new mixer. So if anyone in Colorado has an industrial 40-quart mixer, or even better, a vacuum mixer that they'd like to sell me, let me know. I'd be happy to buy it from you. All right, what are we doing next? Contracts. Test the hammer solid rocket motor and escape the atmosphere. All right, that sounds like a set of things we can do. So we needed a coupler so we don't, die horrendously, which we already have. I just forgot about. And then we need the hammer solid rocket fuel booster, which will give us 1,472 meters a second of delta V. And just for giggles, we probably want some fins to keep us pointing in the general direction that is correct. We'll do 3. And we don't need quite this many mystery goo canisters. And we don't need the bathymetry canister. And we'll keep those other 2. Okay. Unknown comet. What do I wish I prepared for more? I'm going to be honest. I don't think I could have prepared for anything more than I have. Every job I've been has been a unique experience. Whether it was doing the first refurbishment work order for Falcon 9 or helping with crew rating adhesives or designing hypergolic thrusters, I was very lucky that I had a very good education, and I think I was well prepared for the opportunities that I earned in my professional career. Upgoer, this is Upgoer 4. I think I forgot to rename the last one. The Redstone Hive. I make the APCP from scratch in a mixer by mixing it with a mixer. I have a formula that I use that was developed during my time on the MIT rocket team. It works really quite well, and I kind of have a couple of variations on it I use when I need variations on it. All right, let's fly this. So the trick here is we have to start tipping east, otherwise re-entry is going to be really hard on the capsule and the Kerbal. So here we go. If I was thinking, I would have reduced the thrust on this booster before we launched. Jordan, I mean, scores are what they are. You get them, but really they're kind of a measure of how good of a test taker you are. And I'm a pretty good test taker, so I don't think my score really correlates to anything. The Redstone Hive. I get my AP from Rocketry Components Store, RCS Store. It's run by Rosenfield Consulting. They're the people that do Aerotech. So really good AP source. If you do really, really big bulk orders, you can order it from Western Pacific or whoever that big industrial supplier is, and they'll ship you 2,000 pounds. The MIT rocket team bought a couple thousand pounds of AP once. That was a hard one to run by the security people. Okay, this did not go nearly as high as I was hoping for. We will keep that, log that, we will log that. We will log that. Are we going to make it to space? No, we are not going to make it to space. And that. And that. And we will take a crew report. And we will do an EVA report. Cannot disembark while off Kerbal surface until the astronaut complex is upgraded. All right, we will not take an EVA report, I guess. So then we will drop the booster and turn off SAS, and we'll pop the parachute a little later this time. The Redstone Hive. Yes, you do need an L2 cert to buy from there, but I have an L3 cert, so I'm all good. I got my L3 almost 4 years ago now at MDRA. I flew a 5.5-inch diameter DX3 massive kit on an M1560 to earn my L3 cert. It was a beautiful flight. It looked like the rocket never left the launch pad. It was so straight, it looked like it was like going up on the launch rail. I have a spectacular set of video from it, and it's actually on my channel if you want to like poke through and watch it. I had a couple of GoPros on the rocket. It looked amazing. Let's see. Unknown comment. What is the hardest part of being in a field like this? I don't know. I mean, you got to be pretty lucky and pretty smart to be able to hack it with all the other smart people that got in the field. But once you're in the field, you know, I just feel very lucky to be a part of this. Let's see. Oh, hey, Kanan. Hi, Yukon. Do I know about the laws for communicating with the ISS with the radio? The rocket kit, if you are appropriately ham licensed, there should not be any problems. You should just be able to communicate with the ISS on bands that you have privileges for. And the ISS has a ham transceiver and a repeater, and you can pull SSTV images off of it. It's a lot of fun. It's actually something I did a very long time ago. One of my friends who lived in my dorm was doing a project to do it, and I just like came along for the ride. But this should give us a lot of science, and this will let us, I think we'll fly to orbit next. We'll also deploy a magnetometer and do a lot of science. So let's go see what we can do. All right, we got a crew report, mystery goo, temperature scan, atmospheric pressure scan. Yeah, we got 33 science, okay. And we recovered 7,000 funds. So now if we go to the R&D facility, we can grab more rocket parts. And this has even more science experiments, so we want this. We don't have enough science for that. So I guess we'll grab this. Cool. All right, what's next? Colin, do you have any advice for a brand new high school rocketry club? Well, Colin, yes. My first advice is somewhere on my YouTube channel it has an email you can get in touch with me. Otherwise, you can shoot an email to charlie@garciasystems.space. I am always happy to help mentor new high school programs. I've done it for a lot of other programs. I did educational outreach for 5 years before I went to college. So definitely, you should absolutely reach out to me, and I would be happy to sit in on any of your design reviews. If you're doing like SLI, I'd be happy to help you with that. But generically, the two things you need are mentorship and funding. You need a local mentor who's built rockets before, and you need a source of money. It seems cynical to say that, but really rockets are kind of expensive, and you don't have money, you're kind of in a bad spot. So I would definitely look and see if there's any local businesses, if your school will fund you, if maybe there's an alumni in the area that's an aerospace engineer, something like that. It's not a lot of money, or maybe you can do big sales. I funded all my rocketry projects in high school working a minimum wage job as a docent at a museum. But really, it's what you need to get practice. Practice is the most valuable thing. Okay, let's see. So we did the research there. How much is this upgrade? 225,000. So that's, we have enough right now. We'd have a hard time launching rockets. So we have one contract, but we're going to do this back solid rocket thumper thing. And then we're going to go build our first orbital rocket. Yukon, the updates on the liquid rocket program are, I can control my valves, I have COTS valves, I have COTS regulators, and I'm switching my tanks. So my original design, I'm not going to try and pull it up, so you're just going to have to listen to me talk, because I don't know how OBS will like it. But so my original design, I had two identical, I called them propellant towers, where it was a stack up of a COPV, a stainless steel tank, and then a main propellant valve that led to the engine. So each one of these towers could be duplicated, and they were both cryo-rated, so ideally I'd only have to design them once, and it'd work for both the oxygen and the ethanol. And then if I ever wanted to work with, like, say, methane, it would work for that too. The advantage of this was I didn't have any pneumatic systems, no gas-powered systems. And that turned out to not really be the best choice. Pneumatic systems are fast and powerful and relatively inexpensive, so I kind of bit the bullet, and so now I have kind of three systems. So I have the fuel side, I have the oxidizer side, and then I have a third side, which is called, it's the muscle leg. So it provides low-pressure nitrogen to pneumatic actuator systems, as well as to the purge lines. And so what I have now is I have all of the pneumatically actuated valves controlled via a Texas Instruments valve driver that's controlled by a serial. And I'm working with, if you guys know Johnny Hyman, super cool guy. He's on the Flame Trench, I think. He's worked with Joe Barnard before. Really cool guy. But he wrote an awesome test GUI, and I'm working with his test GUI to set it up to control my valve controller, to control the valves that I have, so I can start running flow tests. Okay, what's next? We need to build our orbital class rocket. We're just gonna start from scratch. Okay. Alan, I can't talk about proprietary SpaceX things because I'm on an NDA. But it's really cool, and there's probably like Reddit articles about it if you want to go read up on it. It's like nifty, but I don't think super top secret, but I just don't know what's public knowledge and what's not public knowledge. And then if I say something, then it's definitely like the right answer. So I just can't talk about SpaceX stuff that much. Hello, Paulo. Welcome to the stream. Okay, so we have parachute. Nope, not that parachute, the small parachute. We have the small parachute on top of the capsule, and then we're gonna have a drogue parachute because that's a good idea. And then we need a heat shield. And we're gonna grab a science junior module. And then we're gonna like stick everything on this. So we're gonna put barometer, a thermometer, an orbital telescope. We're gonna put a magnetometer. We aren't going to do this thing yet because this has to be like on orbit for a while. We'll put mystery goo. And we aren't going to use that because we don't have a scientist. Okay, so that's everything. That's like literally everything, including the kitchen sink. So then we'll throw a TD12 decoupler on it, and now we need to get this thing into orbit. So we will throw, let's see, 2 of these and an engine, LV-45, and then a coupler, and then a big solid rocket booster, and we're going to turn the thrust down on this a little so it burns longer. And then we'll do 3 side-along solid rocket boosters. 1, 2, 3. Solid rocket boosters. We're going to make these the hammer ones. And then they need nose cones. So aerodynamics. There we go, nose cones. And then they need fins. All right, how's this for getting to orbit? So if we light them all together, this burns for 995 meters a second. That burns for 765. So then we can come up here and we can ditch one of these, which is probably the right call. There we go. Like that. So that's 1,000, that's 800, that's 600. That's plenty to get, well, that's not really plenty. All right, we're gonna put that tank of liquid fuel back. All right, spacecraft, I think we're ready to fly. So we'll check staging. So we light all of that, then we've got that, then we light that stage, then we ditch that, then we heat shield, then we have the drogue parachute, and then we have the main parachute. Am I forgetting anything? I don't think so, but we'll find out. Let's see, the redstone hive. You just place all the experiments on one side sticking out. Unless I have a service module, which I don't believe I do. I do have a service bay. All right, just kidding. We'll be more elegant. Thank you, redstone hive. This will make things nicer, I think. So we'll put the telescope in and the magnetometer in. Let's just make sure that that doesn't deploy in the way. No, it does not. So then the mystery goo will go over here. And we will get it out of the way of the telescope. And then we'll put the magnetometer, the barometer here, and the thermometer right next to it. There we go. Does that make you guys happy? Did we fix all the problems? Do we have solar panels we can put on this? Probably not. We have a capacitor and we have a battery. We will throw a battery in here just for giggles, because I feel like that might be useful. There we go, battery. Yep, that's everything we got. All right, let's try flying it. So this one's special because it's going to space. And so I'm gonna pick a relevant name. This is gonna be the Hermes 1. For those of you who don't know, the MIT rocket team has an FAA waiver to 90,000 feet on February 1st from the Mojave Air and Spaceport, flying a rocket called Hermes 3. When I was the president of the rocket team, we flew the very first Hermes rocket. It was called Hermes 1. It flew our first home-built solid rocket motor. It was our first minimum diameter rocket. It was 6 inches in diameter. It weighed 170 pounds. And it was really cool. And we flew a Hermes 2 rocket last year, and it regrettably had an anomaly. And then we're flying Hermes 3 this year to hopefully rectify the anomaly we had last year. But the anomaly we have this time is that this rocket is too heavy. And so is the problem the launch pad or the VAB? I think it's the launch pad. Okay. So we will save it. And how much is a new launch pad? Upgrade. Oh, 50,000. That's totally worth it. All right, we're going to do that. Nathan, did I build those reaction wheels? Yes, and actually, if you give me a second, I think they're on one of these shelves. Let me go see if I can find it. Okay, I didn't find the reaction wheels, but I did find some other interesting things for show and tell. This is the battery that ran the reaction wheels. It's a 5 amp hour lithium polymer battery. No, we didn't end up building the reaction wheels for Hermes 3. I just built them to make a point. The point that I was trying to make was that we didn't have a lot of control over the dynamic response modes of the rocket, and it was unhappy. So I built the set, and they decided not to fly them. And then, this is the other fun thing I got. These are my regulators for the liquid rocket engine project. They are 0.6 CV, 4.5 KSI regulators, and they are just awesome. Anyway, show and tell time over. They're really nice. Those regulators are from Swagelok. They're like branded and everything. They're built and aux serviced, and they have PKFE sealed. Oh, I'm really excited to get them in. All right, back to the rocket. We can launch this now. Okay. Greetings, human person. You're just in time for our first orbital launch. Nothing special, just a whole lot of solid rocket motors and a tiny liquid engine. Canine, will I use nitrogen to press up my liquid engine? Yes, I will, because helium is expensive. And also, nitrogen is a lot more available, so it's just like less difficult. Here we go. Up we go. Oh, and of course, there's literally no control surfaces on this vehicle. That was kind of dumb. So we're kind of going to be flying like straight up for the first couple of boosters. This may not work. We'll see. This might be a bad idea. Redstone. Hermes is a Greek god of mythology. He was the god of travelers and healing and messages and a variety of other things. But kind of relevantly, he was renamed Mercury by the Romans. So it's kind of an analog to the US space program, where there's Project Mercury was the first crewed space program. So like Project Hermes is when you're like being funny about that. Let's see. Paulo, H2O2 ethanol. So the problem with H2O2 is that it's really hard to get high-test peroxide from commercial vendors, which means that most people that decide that hydrogen peroxide is their one true oxidizer have a rocket engine hobby that becomes secondary to their homebrewing high-test peroxide hobby. And the thing about making high-test peroxide is that it's difficult and dangerous. Copenhagen Suborbitals tried it, and it was not. They decided that high-test peroxide was not worth it, and that liquid oxygen was a better propellant. Let's see. Will I attempt retropropulsive landing with the liquid rocket engine, chasing Joe? So first principle, just for the record, the liquid engine is a ground test article for now. I would love to fly it. It needs to work first. If it doesn't work on the ground, it definitely won't work in the air. But having said that, it does have a throttleable dynamic pintle element with phase shutoff, so it should be a good candidate for a retropropulsive landing vehicle. Its thrust level is relatively high. At 6,000 pounds, it will need some pretty sporty guidance to get back onto the ground in one piece. I think Joe's liquid engine that he's working with another friend of mine with a much, much smaller engine to start with. But it would definitely be an exciting and cool thing to do if Joe wanted to work with me on that. Let's see. Nathan. Oh, yeah, see, man. Good luck with your control theory and physics. Yukon. Remember, I am no longer in Massachusetts. I am in the lovely state of Colorado, which is just as cold. I don't think we are likely to get into orbit with this. I think that we did not have enough control theory. But 143. We might. It will be close. I don't think we will be high enough that we will get this done. But we will try. If nothing else, it will be better for our Kerbal to come in sideways instead of straight down. Let's see, we've got 400 meters. Yeah, we aren't going to make it to orbit. Sad. Human person. There's basically no difference. The difference is whether they're pressure fed or pump fed, and whether they're gaseous injection or liquid injection. But it's essentially the same thing. RCS thruster is just another name for a small rocket engine. The Redstone Hive. I don't really. The problem is not the SRBs. The problem is that I am not sideways enough. I had plenty of Delta V. I just couldn't use it very effectively. But we will still, we will. We'll make a mission out of it, and we will do while in space near Kerbin. Crew report. We will open up the experiment bay, log visual operations, extend the magnetometer boom. We will get the mystery goo. We'll use this as a wet dress rehearsal. This is like the first Mercury mission. This is like Freedom 7 before, we actually went to space. And the thermometer, or was it Freedom 7 or Friendship 7? It was one or the other. I don't remember. We need to retract this. And then we need to stage off that. Point retrograde. And then we've got our 2 parachutes. Now all I have to do is fall. Okay. Make a full liquid rocket main stage with SRBs to support it. That's definitely an option. We could use the LE45, LR45, whatever it's called. The LVT45, I'm sorry, instead of the LVT30. Let's see. I do have reaction wheels. I just don't have, they don't have enough torque in the atmosphere to steer those SRBs. Thorgon, a drag wasn't the problem. The problem here was definitely just that I didn't have enough control authority to point the spacecraft the direction that I wanted to be traveling. It'll be okay though. We'll get science from this, and we will then do something interesting in a minute. Oh wow, this is not passively stable. That was bad. All right, guys, we're gonna be flying a sporty entry. Uh-oh. Houston, we have a problem. Yep, problems. We are having them. They are occurring. There are problems occurring. They are big problems. Our entry was too steep because we didn't make it to orbit, and now we are toasting ourselves. Uh-oh. Ah! 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 We're flipping out of control. Uh-oh. Our parachute is going to die. This is very bad. I'm going to do a barbecue roll to keep everything from overheating. I'm so sorry, Jeb. I'm so sorry. Oh, wow, he might survive. Okay, all right. Drogue parachute. We need to deploy it soon because we're kind of over hilly terrain as opposed to like ocean, which would have been convenient. Maybe we'll reach the ocean. But there's a drogue parachute. And the drogue parachute should inflate at 2,500 feet. Oh, we're over water, thank goodness. So there's the drogue parachute. And then we will drop the drogue parachute and deploy the main parachute. There we go. All right. All right. While this lands, I'm going to go grab another drink, and I will be right back. Welcome back, everybody. I'm here with another beverage, and our spacecraft is here and on the ground. So let's recover it real quick and try again to reach orbit. Paulo, 50% peroxide is still not enough to be a rocket fuel. You need at least 70% and sometimes closer to 90, depending on what catalyst you're using. Let's see. Did I miss anything else? Nope. All right. Hello, Platinum. Welcome. Thank you for joining us. We are on a quest to reach orbit in career mode. Let's see. We got 50% value from that. Did we get any of our contracts done? We have no active contracts. So let's see. We need to orbit Kerbin. We can take that contract. Let's see. Study of Kerbin. Study of Kerbin somewhere else. Hall of Flea, solid rocket booster. That's not really useful. All right, which one of these contracts we're going to try? Oh, this is like vaguely useful. All right, no, this is definitely the best other contract. All right, we're going to take that one. All right, so how do we fix the exploding material science bay? Because I wasn't supposed to do that. For those of you who are curious, this is a dirty Shirley. It's a Shirley Temple, and it is really tasty. Yukon, I'm unfamiliar with Vortex rocket engines. What are Vortex rocket engines? Maybe we can be sketchy. Nope, you can't surface attach these. I do have these widgets. What other options do I have for attaching things? Yeah. Nope, that won't do it. I need something with an attach node. This might. This will. Here we go. All right. So what we're going to do, we're going to take this, and we are going to use it to jank another heat shield onto the side of this rocket. You guys see how aerodynamic this is? This is a big brain move right here. There we go. And then we had control authority problems. So we're gonna swap these cheap things for these things because I'm lazy and it's faster to do this than it is to build an entire middle core of the rocket. You guys see this? This is lowest cost bidder development work right here. Solid rocket powered center core, liquid rocket boosters. It's almost as janky as Antares with its solid rocket powered upper stage and liquid fueled first stage. Okay, save that. All right. Am I able to EVA? No, I am not. Did it explode on reentry? Yes, it did. Put the service bay under the science bay, but then I would lose all of my experiments except for the material science bay. Let's see. But whoever suggested that I get myself set up to be able to do an EVA is correct, and I'm going to go take care of that right now. Brazilian soap, if it works, don't judge it. And if it doesn't work, we'll just try again. expertise is cheap to get in Kerbal Space Program. So we need to upgrade the astronaut complex, which is 75,000 Kerbucks. Max active contract 7. That's not a bad gig. How much is this? That's 220,000. That's more useful. Hermes 2. Hermes dose. Too many parts. That's unfortunate. We can do this one quick. So we're gonna, oh. Well, we can't. Phooey. All right. We need money. Or we need to take parts off of Hermes 2, which we will do. All right. I think I need to remove 8 parts. Yeah. That's 1. That's 2. That's a lot more than 2, actually. There we go. That's what we needed. We're going to turn the thrust even farther down on that. $1,700, $2,300. That's not a lot to spare. And that's 30 parts right there. So what we're going to do is we're going to swap these to be single boosters. And we're going to add fuel up here. There we go. Science. We did it. Look at us. Sciencing. All the science. So this has a TWR of 2.7. This has a TWR of 0.72, so we should fix that. TWR of 0.93, so we should fix that. TWR of 1.3, that's good. And TWR of 2.5, so if we sum up that, that's 1,100, 2,500. All right, that is enough that if we fly relatively efficiently, we can do this. You know, to be honest, I don't think this is going to help. I think we're just going to fly the descent and entry better, because I want that fuel here. Like that, and then we're going to take this back to 50. All right. Hermes 2, trying again. Redstone Hive, I don't have any mods that let me recover stages with parachutes, so I'd have to fly them individually, and I'm not sure that they would get to the ground before we got out of render distance. But we'll find out. All right, here we go. .30-kilometer apogee. .35-kilometer apogee. 40-kilometer apogee. It's is actually going to be pretty... we've got plenty of delta V. This will be okay. There's no problems here. Yeah, if anyone knows what that pig square is, I suspect it's probably an unloaded asset for an IVA, and it's probably a mod conflict. I just don't know which mod or what asset is unloaded. Thorgon, vortex engines inject fuel at an angle, spinning it and creating a vortex that does not touch the nozzle. It is unclear to me how the vortex would not touch the nozzle when it would have centripetal acceleration outwards that would require it to have a smaller boundary layer. No, I don't believe that. Is there like a paper on it? Because I don't believe that in bell nozzles that does less work. Plasmium. Yes, I have seen the Real Plume mod. Plasmium. Oh, it's Planet Shine. I do have Planet Shine installed, so I might actually be able to fix that in here. What if I just do that? Advanced. Can I just turn it off? Does that fix it? No, it doesn't. Alright. I don't know. It might be Planet Shine. I'll try and fix it before next time. Let's see. Oh, and we now need to throttle up. I almost missed it. That would have been bad. That was kind of dumb. Herder. Woo! Alright. Well, you know what? We can make the pink square hide by... No, we can't. I used to be able to look at the thing from an angle and make the pink square go away, but it is no longer hiding from us. 250. Oh, wow. I kind of went a little higher than I meant to. Well, we can do an EVA report from the upper atmosphere. And then we can go up to apogee and make it into orbit. All right, so once we get into orbit, we'll take a little more science, and then we will come back. That's us in orbit. And then we need to test the heat shield, which we will do. So let's do some science real quick. Crew report. Materials science, observe materials bay. Keep that. EVA. EVA report. Oh, right, you can do EVA reports over all the different biomes. Well, that's tedious, so we're not going to do that. We're just going to come home. And everyone has to remind me, because we have to make sure we run this heat shield test at the right time. There we go. Fumble fingered it a little bit. Periapsis. There we go. All right. You know what? We're going to raise our periapsis a little bit so we don't come screaming in quite so hot. Like maybe, say, 35? Let's see. Am I drinking rocket engine coolant or what? Well, this is really low-grade rocket fuel if it's rocket fuel. But there's a little bit of ethanol in it. Do I know a good place to find legal information about every type of rocket engine? The Rocket Kit. No, I do not. It depends on where you live. For example, some cities have rules about where you can test rocket engines. Sometimes it's the state level. Like California is really obnoxious about rocket motors bigger than M motors. Sometimes it's the federal level. If you're flying, you always need to be talking to the FAA. If you're using black powder, you need to be talking to the ATF. If you're using some types of low current initiators, you need to be talking to the ATF. It's really just, you got to know what you're doing. All right. So we're going to raise our periapsis just a little bit to 35 kilometers. Maybe 30 kilometers. There we go. And then we're going to go back to retrograde. And we're going to slam on the brakes right before we hit the atmosphere to try and baby this materials bay so it survives. The Redstone Hive. G-powered rocket motors can always be considered high-power rocket motors depending on their thrust. It is a thing that can be a thing. It just sort of is. I didn't actually fly any G motors until I got to college. Even though I'd like tested J motors on the ground, it wasn't until college that I actually got to fly any. Let's see, we'll close those doors to try and help protect it from the heat. We will slam on the brakes. And then we can run test here, which got us that contract. And then we can stage off that. All right. Now that we've done that, I think it's just a matter of surviving re-entry. Plasmium. Everything gives you cancer according to California because California funds state research organizations to figure out what will actually give you cancer. California is not being obnoxious. California is being obnoxious to people that are trying to take advantage of you. In most cases. Sometimes they're just being obnoxious. But in general, like there's formaldehyde in a lot of MDF. And because California has laws against it, and like a lot of people and a lot of money is from California, now MDF has less formaldehyde in it, which is good for you, and you not getting cancer. Come on! Why are you overheating? I mean, I know why you're overheating, but it's still frustrating. All right, well, I guess we're losing this material science bay too. Do we have any lift? A little. There we go. That helps. There we go. All I had to do was target the retrograde vector better, and we got less heating on the material science bay. Matthew, it's very tragic. I hope that Skorsky figures out what happened to that helicopter and is able to quickly and safely improve it for everyone else. I don't know enough to say what happened now that made the helicopter crash, so and then there's no like technical comment on it, other than, you know, it's obviously tragic. Whenever there's any kind of aerospace disaster, whether it's Skorsky or 737 MAX or whatever vehicle it is. All right, well, we got it through re-entry. That was only a little bit challenging. Looks like we're going to be landing over land, unfortunately, but we'll get the drone parachute out. As long as we don't land on these mountains here, I think we'll be pretty okay. All right, so we've been to orbit. What's next, guys? I could take any kind of contracts that they offer, so it's just kind of a question of what we want to try and see. Any suggestions? We're gonna try a low-tech Mooner mission. Minmus? Minmus is easier. Or we're just gonna like go up and collect science. Plasmium, like I said earlier, I can't talk about SpaceX stuff. It's all under NDA. But I will say, just from a personal note, it was really, really cool to see it finally happen. IFA has been kind of on slow burn for a while. Redstone, you get a lot more science from bringing it home. All right. And we will recover that. All right, I see a request for a Minmus landing. That sounds promising. Let's see if we can get any contracts to pay for us to go to Minmus. And the first thing we're going to do is we're going to pay for this. And we're going to buy parts here. And we have 100 science left. So we could go up this tree and get some 2.5 meter parts. That's not really helpful. What are these? Cargo containers? Minerals, uranium, stuff like that. We can come down here. This has surface experiments, which might be useful for Minmus. More antennas. A transport platform. This has solar panels. More experiments. Probe cores. Probe cores might actually be... All right. Change of plans. We're going to research this. And we're going to build our first uncrewed vehicle. All right. First uncrewed... So we're going to build a ScanSat mission. Brazilian soap, the interesting part about Gilly is trying to stay on Gilly once you've gotten there. If you just like bounce too hard, you're up and gone. All right. New thing. We're going to start with this probe core. And it needs power. That, and we will get some solar panels on here. 6, 8, 6. All right, so we got that. It needs comms, so we will throw one of these on it. We got all the lasers flying off of this thing. The lasers are from Near Future Communications. Okay, then I needed science. So we want to put the altimetry sensor on this. Like that. And, you know, it'll look cool if we put one of these on it, too. Doesn't make it that much more expensive. Okay, so now we've got all that. Am I forgetting anything? Let's see. So we need a coupler. Put a tiny decoupler on this. Do I have any kind of payload fairing? Well, no, I have no... payload fairing. Oh, that's cool. These are nifty parts. I like those parts. All right, so we are flying. No plasmium. I do not have MKS installed. And a tiny engine, and then a decoupler, and then a bigger engine. This is like the first rocket you could build in Kerbal Space Program. It's like 4 tanks of liquid fuel, an LV-909, and an LVT-45. I remember when the LV-909 got added. That was like a big deal. Let's see. We've got 1900 meters a second and 900 meters a second. Yeah, that's everything I think we need. Maybe some fins for aerodynamic stability. There we go. That's a rocket. What are we going to call it? It's going to be the Sensitron 1. There we go. Brazilian, what does RP1 like series mean? Oh, wow. Isn't that pretty? Look at those clouds. That's spectacular. Okay, going up in 3, 2, 1. What is Ready Player One? I'm familiar with like the book. What would my series be like? Let's see. Oh, wait. There we go. Just kind of fly. Oh, realistic progression. No, I'm not going to do a Kerbal Space Program series. I enjoy playing the game for fun, but editing videos actually takes like forever. You can tell because I've filmed a lot of Liquid Rocket Engine episodes and I just haven't edited them because editing them takes like 10 times longer than filming them. At least if you're... problems. We're having problems. There are problems. Just thought everyone should know. All right. There we go. And we got it back. Everything is okay. There are no more problems. Yeah, when I want to play Space Program with realistic progression enabled, I go to work. It has one of the best realism mods enabled called Bureaucracy and Budgets. All right. Everything is okay. There are no problems. We are definitely not flipping out of control and backwards. There we go. Nope, nope, we're losing it. There we go. Nope, uh-oh, okay. Problems. We are still having problems. There are problems. Uh-oh. This may not be going to orbit. It's got the Delta V, it just doesn't have the control. It is, in theory, still possible to get this to orbit. We have the TWR. All right. This mission, I think, has been successfully salvaged. 75 kilometers. maybe target like 250? Yeah, there we go, 300. Hi, Matt. The purple thing is a glitch in one of my mods that's not supposed to be there. I have it on good authority that it's related to Planet Shine somehow, but we'll fix it next time we load the game up. Yes, we will get fairings soon. Alec, this one will not land. This is an uncrewed probe core doing radio frequency measuring of things from space. Plasmium, we don't need any shade thrown here. Blue Origin's a cool crew too. Actually, right after we get this into orbit, I have something to show related to that. All right, we're like 9 kilometers away from apogee. There we go. Oh, well, that's not really what I wanted to do, but that's where I am. Okay, start scan. We're gonna flip retrograde actually and fix that just a little bit. There we go. There we go. All right, deployed. Then we'll deploy the magnetometer boom and log data. And let's see, can we pull up ScanSet? Yes, there we go. Is it working? Yes. Okay, cool. Let's see. I've been streaming for an hour and a half, so this is what I was going to show people. I have a Blue Origin shirt. This was really cool. I got this at their factory in Kent, Washington. Last time I was there, and it's got this really awesome like back to it. I don't know if you could see it, but it's a really nice shirt actually. Do I have any way of getting power? Yes, there are static solar panels on this. Oh, God. I flew a mapping satellite into an equatorial orbit like a total idiot. Ah. Can I get an F in the chat, boys? All right, all right. Well, that was stupid. All right. All right, well, we'll complete one orbit just to say we did. And then this thing is useless, even though it exists. All right, we'll do one more mission. We'll go to the moon, and then we'll call it a stream. So what science experiments are going on our lunar exploration? Well, we need a capsule. Parachutes. Heat shield, all the basics. Coupler. Let's see. So this is going to be our return stage. So it needs 700 meters a second. All right, min-miss. All right, we're doing min-miss. 700 meters a second of delta V. So if we set this to vacuum, yeah, that's plenty. Okay. This is our min-miss ascent vehicle. Our min-miss lander is going to look like this. Let's see, science. That. We can bring along one of these. Bring along two of these. Orbital telescope. Barometer. Thermometer. Magnetometer. I'm just adding all the ohmmeters onto this thing. Mystery goo. We need a mystery goo, obviously. Electrical, we will add 2 solar panels. This thing needs engines. 820, 390, so this is the cheapest one. Alright, utilities. Do we have landing legs yet? That could be interesting. No, we have no landing legs. We wouldn't want this to be too easy. Alright, no landing legs, what do we do? Night, Jordan. No landing legs. So in the old days, the fins that the first fins you got looked different, and you would do this. Is this still a trick you can do? Yeah, it is. All right, these are our landing legs, folks. Check it out. Landing leg. All right, so now I need a transfer stage. Just out of curiosity, how much delta V is that? Oh, that's the transfer stage right there. So then we need an orbital insertion stage, which is going to be like dirt simple. Decoupler. How many parts can I do? 255. I can do a lot of parts. 1, 2, 4. Another LVT45. And then fuel tanks with some LVT30s. That. Nose cone. Under aerodynamic. Some more fins. Big fins this time. And then the engines. Alright, what do we call our Minmus mission? Minmari Lander 1. There we go. And now real quick, we're going to go see what... I think we can get another 100, so we don't have enough money for that yet. We can do that. Let's see, are any of these, let's explore the Mun. Alright, this is an easy one. This is an easy one. So we're going to just take those two, and we're going to gin up a rocket together real quick, just for testing purposes. So we'll save this. This is 46,000 Kerbucks. We'll take you. And then we will grab you. And then we need you. And I heard someone say, and they may be right, that the landing gear is no longer under the utility tab, it's under the gear ground tab. And you are, of course, correct. Thank you, guys. They changed it on me. That's what you get when you've played a game for 9 years. They move stuff on you. So we're just going to run this test real quick, and then we will go back and fix the rocket. Oh, it's so tasty. Yes, Brazilian soap. If you land soft enough, you don't need any landing gear. But that relies on your piloting skills. And piloting skills are often in short supply when you're talking to me. So we will do that and get that contract done, do that and get that contract done, and then recover the vessel. Woo! Just like that, 10,000 bucks. But what I really wanted to do was not the money. What I wanted there was I wanted the contracts to reset. I wanted to see if we could get some Minmus contracts. So now if we upgrade that, or any of these for Minmus, Kerbin, Mun, Kerbin. All right, we're going to the Mun. Yeah, we're going to the Mun. Let's see. Launch pad. Minmari Lander 1. So we're going to take this beautiful mission, and we are going to, instead of flying it to Minmus as we planned, we're going to do a really fast flyby of the Mun, because that's what they're paying us to do. Remember how I said I had the bureaucracy DLC? This is what happens. If you guys follow NASA's appropriations budget, NASA just had a new budget proposed in Congress, and it does a good thing, which is cancel Gateway for the Artemis program. But also does a bad thing, maybe, possibly, by canceling the plans for a long-term stay on the moon and instead dictating that we should be doing a flyby of Mars by 2032. But Congress sets the budget for NASA, so they get to decide what NASA does. So we don't even need landing legs for this mission. So we're just going to launch this. Okay. I don't really use scientists that often. I'd rather have a pilot on board that can do the piloting features, because it's, you know, pretty easy just to fly another mission if you need more science. Alright, let's see if this works. There's no, like, struts on any of this, so it could be just kind of a floppy mess. No, Redstone Hive. The latest appropriations bill has proposed canceling Gateway, which I think is a good thing. I think Gateway's... Uh-oh, problems. What happened? Abort, 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 abort. Alright, that was exciting. The purple square helps you guys keep track of where all the astronauts are dying. Alright. Well, that was fun. Let's try this again, but not fumble fingering the staging key. Alec, I did not particularly like Gateway. I always thought Gateway was a gimmick. And the reason why I didn't like Gateway... the reason I did not like Gateway was very straightforward. It required the Artemis lander to be 3 stages, so it made the idea of a long-term stay on the moon very hard, because each lander was inherently disposable. Like, you couldn't have a reusable lander. And the reason that is because Orion is underpowered. It didn't have enough delta V to make it into a low lunar orbit. So Gateway had to be in this really high-out orbit, so you couldn't just, like, it would have made sense to do a Gateway in, like, low lunar orbit where you, like, flew Orion to the Gateway, met up with the lander, took the lander to the surface, refueled the lander on the surface, came back to the Gateway, got back in Orion, and went home. That makes sense. But Gateway was in this really funky orbit that didn't do anybody any good and required the lander to be 3 disposable stages. 3 disposable stages! Like, that's not how you do long-term stays on the moon with, like, constant human presence. Throwing away the lander every time. I thought we learned our lesson. And landing on the moon is easier than doing, like, reuse of the first stage, in my opinion. So I don't know why it took that long to get there. Checking our staging again. Yes, yes. There. There. All right. Sorry, did I get a... Yeah, Plasmium. Gateway was going to be in a very eccentric orbit, which was going to require a whole stage of the lunar lander just to circularize into a low lunar orbit. And then the next stage of the lander would be to go from that low circular orbit to landing. And then the last stage would be an ascent stage to get back to orbit. Plasmium, if you play Kerbal Space Program, you know that's not how orbits work. If you're in an eccentric orbit, you still have to cancel all of that momentum. No, Redstone, the lander was never going to be fully reusable. Alright, well that was exciting. This is what I get for talking instead of playing. We're coming up on main engine cutoff here in a second. That's booster engine cutoff. We're going to flip around again a couple more times. Wow, you know, this rocket just wants to be flying the other way. Do we got a TWR of 1 on this thing? We do. Alright, back to the vehicle assembly building. We're trying again. The way to fix this is actually quite straightforward. It's just to take these off of there and put them there. Yeah, Redstone, it's obviously not a good design, but where's the fun in just giving up on it after realizing it's a bad design? That would be, like, wise and betray some engineering judgment in me. Alright, trying this again, as we launch from the Terminator on Kerbal. This launch is going much smoother. See? What a great design, guys. There's nothing wrong with this design. Absolutely nothing could be improved. Plasmium. You probably can't because you'll have a relative velocity of several hundred meters a second between the lander and the station. So your idea of docking would be more like crashing, and neither of them would exist anymore. Alright. So just for the record, if you couldn't tell, efficiency's kind of out the window here. There's enough delta V on this thing that I don't really have to worry about efficiency at all. So I'm just kind of like doing it all by eyeball. Alec, parking a starship in orbit around the moon would still not fix the problem with Gateway, which is that it is designed to be in the wrong orbit. Alright, so you need to get up to 135 kilometers, and then circularize. There we go. Yeah, so Gateway would only make sense as a stepping stone to Mars if it was a propellant depot. And given that propellant depot is still a dirty word at NASA because it might endanger the millions and billions of dollars being thrown at SLS, I don't think it's a politically viable idea. All right. So we want to go dock with Minmus. And I don't have maneuver nodes yet, which is awkward. So we're going to eyeball it. Excuse me. All right, so remember how I said we had plenty of delta V? That may be less true now that we have to eyeball all of these maneuvers. Brazilian soup. So I think there is no chance that NASA does not continue the SLS program. SLS is a third rail of politics. It is too important to too many senators and representatives districts and too many national defense contractors that provide other critical services and need contracts in between their military contracts for SLS to ever be canceled. And that's not to say SLS is a bad program. Like, SLS has definitely done some cool stuff. I have my issues with it, but, like, supporting, like, important parts of the national defense complex is, like, a thing. This is, let's see, I want to be going down. This orbit is not the orbit I really want. I'm still not really thrilled with how this is turning out. I wish I'd waited a little longer before starting this burn. Oh, we were going to the moon, right? I forgot. Are we gonna fly by the mun? Yep. Accidental mun encounter. Spoiled again. All right, well, we'll take our science, and I forgot to put science in the science bay because I'm an idiot. Excellent. Very good. Open doors, observe materials, keep that, do that, keep that. Log magnetometer data, yes please. Log radio wave data, yes please. I think I put a telescope on this one, I did. Let's log visual observations, which we will take. And grab pressure data. And temperature data. There we go. All right, so I need just a real quick EVA to collect all the things, and then we will be going back to Kerbin. Brazilian soap. NASA has never done anything alone. Anyone who thinks that NASA ever did anything alone is wrong. Like, even the Apollo program was like a conglomerate of like thousands of subcontractors, right? Like, they did the guidance at Draper Labs, they did North American Aviation and Grumman Corporation. Yeah, I mean, NASA never has done anything by itself, and that's not a knock on NASA. That's just the way the system worked, and it worked very well for a lot of programs. SLS was not going to be canceled ever, so, I mean, it's just kind of you have to make your peace with it. I mean, Plasmium, they didn't know what they were getting into. I mean, you couldn't... They still have to do refurbishment work on other reused rockets as well. I mean, it's just a fact of life. CST-100 and Dragon 2 are both planned to be reused. They'll need refurbishment. Space is a harsh environment. The one part of the shuttle program that was an awful idea to reuse was, of course, the SRBs, which was an awful idea. They did not like the saltwater bath they took after every flight. Take data. Oh wow, this pink square is going to get very obnoxious very quickly. Take data. Take the data from that. Speaking of which, I need an EVA report. Take the data from that. Remove data. And from this, we will take the data. Take the data. All right, that should be everything. We can get back in now. Any second now. Any second now, I said. All right, there we go. We can take a real quick crew report. The Redstone, I can't answer SpaceX questions. Brazilian Soap, the reason they canceled the shuttle program was actually because they couldn't keep flying shuttles when they kept losing shuttles. The shuttle program was doing pretty well. It wasn't even that the orbiters were old, it was that they couldn't get any new orbiters. So if they lost another orbiter, the program was going to be inviable. So they either had to find a way to buy new orbiters, or they had to come up with a new plan. And they decided that given how old the orbiters were, a new plan was a better idea than buying more new orbiters. The Redstone shuttle was not particularly safe, but there were a lot of contributing factors in its cancellation beyond just the fact that it was unsafe. And it's the chance of a loss of mission for shuttle contributed to the cancellation of shuttle, not just because it was hazardous, that was a known and understood risk, but because you couldn't guarantee that there would be a vehicle that you could, that you would have a vehicle available when you needed it to fly missions if you needed to fly them. All right, retrograde. We'll try retrograde. Yeah, Brazilian Soap. Before the Challenger disaster, it was about 60,000 hours of refurbishment in between flights. After Challenger, they averaged about 1.1 million person hours of labor in between shuttle flights. And I mean, partly that was because like the shuttles did not get as many test flights as they wanted. But also, everyone was okay with the number of hours that were put into refurbishment. Like that was like an okay thing. The thing you have to remember about national space programs is that they are not optimizing for the same set of goals that, say, SpaceX is. It's just not what they're trying to do. No, definitely was not realized that it was better to fly Soyuz. The U.S. government was not super thrilled about having to fly on Soyuz. They thought commercial crew was going to be available much, much sooner. They thought SLS was going to be available much, much sooner. But so the decision was definitely not made to trade shuttle versus Soyuz. That was not how that call was made. All right, we are almost done here, and then we will call it a day. And next time we will pick up setting up some infrastructure for our antenna relay system. There we go. Where are we going to land? We're going to land in the crater, aren't we? No, we are not going to land in the crater. Never mind. But we might land on land, which is not, like, super awesome. We will, however, blow off the rest of this liquid fuel before we let go of the stage, just to make the reentry a little gentler. There we go. And we will get some lifting body on our... So by flying with this kind of angle, you get a little bit of lift. In addition to your drag, so you can see you've got that little lift arrow, and that slows down the reentry, so you get less total heating, and also the G loading is lower. Alright, now all we gotta do is slow down enough to get the parachutes out. We can call this mission a success. Sorry to disappoint with the lack of booms. I know that's what everyone watches Kerbal Space Program for, but... Yep, Brazilian Soap, I am done for the evening. Thank you all for joining me. I think this was a fairly successful start to a new save file. The next stream is not likely to be for quite some time because we've got a launch next weekend, but with any luck, the next time I do stream, I will have really cool flight video to show you from a rocket that went to 80,000 feet. We got 170 science. How about it? Nice. And the tracking station. Cool. All right, well, that is it for me. Thank you all for watching, and have a wonderful evening.